Hey everyone, you're listening to the Simple Electronics podcast. I'm your host Dan from the Simple Electronics YouTube channel, and this episode is sponsored by PCBWay, but more about them later. So today I have no guests at all. It is just me and you, I suppose, because the listener is the most important part of this podcast experience. I've been extremely busy lately, as seems to be the theme. But I have to say, it's a good busy. So I've been busy because I've been working on more in-depth videos, one specifically, and I'm working a teaching contract again, which is great because I did not expect to get one. So I have 8 weeks of teaching. I think this is week 3 at the moment. And then I have 8 more weeks after this 8 weeks that were sort of, I guess, promised to me would be the proper term for it. But that doesn't mean I'm going to get it. I don't have a contract for that one yet. So right now I'm just relishing in the fact that I have 8 weeks of contract when for a little while there, it didn't look like it was going to go through at all. So that's pretty good because anytime that I get to sort of do my passion is a great time. So here we are. Also, because of that, I had to shuffle around my streaming schedule a little bit. And so the Monday morning, live gaming streams, pure recreation. So if you're into electronics, this is probably not for you on twitch.tv/simple electronics YT. That is still happening 8 a.m. Eastern time on Twitch. I'm playing Terraria at the moment, which is a great little 2D game from an indie creator. Indie creators, there's a couple of them, and it's a very cheap game. So if you want to, check it out, it's very inexpensive to get into. Great little game. But my electronics stream, because the stream time before is actually when I'm working at the college, I moved it to Saturday evenings or afternoons, 2 p.m. Saturdays. Check it out if you're into electronics and stuff. It's really nice to chat with you guys while I work on future content. And very recently, I was able to release the first video that I have been, first completed video that I have worked on the live stream. So that's been pretty nice. So let's talk about that video right now then. So just like a lot of my video ideas, this video came from a need, a requirement that I had. Basically, probably a lot like you folks listening at home, I have gained a whole bunch of sort of battery powered, lithium battery powered equipment, gear, phones, camera batteries, stuff like that I need to charge. And sometimes I need to charge them all at once. And there's a couple solutions to this problem. You can go on somewhere like AliExpress or eBay and go buy like a bunch of these power bricks, and you can plug in, 4 devices on these power bricks. But the issue is then, if you have a couple of devices, then you need a couple of power bricks, and it takes up space. And at the same time, you kind of have to find like a plug where it's convenient to rest something on. Like I can use my kitchen counter, for example, but then it's kind of in the way. I have some space in my workshop here, but not a lot because horizontal space comes at a premium, especially if you have a smaller living arrangement, kind of like we do over here. So I am I'm embarking on a journey to build a sort of charging station where I can charge a lot or most of my devices all at once whenever I need to. And the first step of that is the project that I have just published as of the recording of this 2 days and 21 hours ago, which is a PCB that plugs into a power supply for a computer, which is a great place to get, multiple voltages for relatively inexpensive. And this PCB has a whole bunch of USB plugs. They have 6 double stacked USB sockets. And so in principle, I can charge 12 devices from this PCB at the same time. Even better than that, though, is I can take off the 5-volt power from this PCB to another identical PCB with another fuse and whatever I need, and then solder on another 6 of these double headers. And so I can actually increase from 12 to 24 devices all at once. And the PC power supply should be easily able to handle that amount of current. I definitely want to reiterate something, though, for the commenters on that video, is that they are telling me that I need a chip to control the charging via USB. That is not true, actually. The control for the charging is controlled on the host side, like on the device side, not on the charging side. This is one of the things that I found out while doing the live stream. So I can just dump pure 5-volt through these USB connectors and they'll be fine. In fact, that's pretty much what your computer does, especially if you have the standby 5 volts. It's just regulated by the power supply, so that's not an issue there at all. Next thing is that you don't need a power delivery chip. The power delivery chips to do the negotiations with the device is only if you want rapid charging. And so you don't really need rapid charging for most devices. Rapid charging is more for like power banks and cell phones, those kinds of things, because you want to charge them in shorter periods of time. For me, I don't care if I, plug everything in and let it charge overnight, because the lithium charging is handled by the onboard, the device side stuff. So like camera batteries have internal PCBs. Even 18650s that I have to charge here, which are lithium cylindrical cells, they're handled by like a TP4056 module. So I really don't have to worry about any of that. I can just plug things in and let it go ad infinitum, which is the dream, right? To have a little shelf somewhere where I can charge all my devices. I would like one day to build a quick charge compatible, like a power delivery compatible PCB for a little bit of the higher end stuff, because I don't know if you've noticed, but those the chargers you can buy that plug into the wall and deliver up to 60 watts of current or whatever, they're actually really expensive. Here in Canada, they cost anywhere between 50 to 60 to 70, up to even $100 for a decent quality one. And although I'm not a fan of charging my phone at really high rates, because I feel like the higher the current, the more you're like shortening the life of the battery, it is interesting to see that it is available, right? That much power delivery is available. And it would be nice to power things, on the go, sort of like, a soldering iron, like a TS100 or 101 now, I think is the new one. So those kinds of things are intriguing to me, but it's not something that I need right away. The immediate need is a spot to, charge all my devices. Now, in terms of what I have designed as a PCB, I feel like I allowed myself to get a little bit of feature creep put in. You see, I was thinking of using this as the base station, like the base PCB, to take power out of a computer power supply. So I have a 24-pin socket that you plug your motherboard's 24-pin socket into, and you can flip it on and off with the switch on board. However, I was thinking this might be more useful to more people if I redesigned it with just like a Molex connector on it. So people can just plug in a portion of their power supply and then use a 24-pin elsewhere. So I might rethink the design of this to only deal with the 5 volts, and maybe even have like a quick charge section for people's phones. Maybe it'll be more useful overall to have a project that sort of has, let's say 4 ports or 6 ports of regular, dumb charging, and then one port with the quick charge capabilities or something like that. I'll have to see. These are all things that that I'll take into consideration in the future, because once you have the footprints of the devices, like the USB sockets and whatever, spinning up variations on that PCB is not actually that difficult. And I would be interested to know, like, what layout would be the most useful for people, because I would love to design something to be used for, by most people. I don't really usually use, I don't really talk about PCBWay too much during my podcast and just keep that for the ad spot. But I guess this one can be more integrated, because what I love about PCBWay, and don't skip this because it's not really, well, it is a sponsored segment, but you'll see what I mean. What I love about PCBWay is I get to use my relationship with them and design things that people find useful. Like, for example, someone left a comment on the Atari Punk console PCBs that they ordered them, soldered all the components, and it worked perfectly, and they were enjoying making sounds out of them. And so the fact that I designed something that other people enjoy and use is pretty awesome. In fact, in the same vein, my relationship with PCBWay, and then my knowledge of how awesome Steph Piper's PCBs are, pushed me to make fancier PCBs. Right, they look better, and I was honored when Steph Piper messaged me and said that she ordered some PCBs off PCBWay, of the My Christmas Wreath ones, and she put them up on a board with a whole bunch of other PCBs which she liked the designs of. And so really, to have that kind of feedback from someone I admired their work was really like boosting to my self-confidence, I guess. And so, yeah, I guess I'll reach out to the viewers now and tell me if you want a different form factor, a different, style of USB charger like that. Let me know so that I can design them and send them off to PCBWay to be built. And then all you have to do is then you just download, you can either download the Gerbers yourself. It'll be uploaded on PCBWay's website. You either download the Gerbers yourself, or you can order them directly from there. And it's about $5 American plus the shipping. But if you take the slow shipping option, it's like another $7 or $10 or something like that. And so you get 10 PCBs for about $15 US, maybe let's say $20 US, to round it all off. And so really inexpensive, and you get 10 PCBs. So if you only needed one or two chargers, then you can build some more up for your friends and family or whatever. So that's a thought, at least. I was really proud of how that project came out, but I do see some improvements, and yeah, that's why I like the community feedback, so I can make improvements and do things a bit better. But either way, for now, it's solving my issue, which is I need to charge multiple devices at once. Now, another part of charging all these devices at once is that you need to actually have wires. Right, you need to have USB cables, and I'm not sure how it is in other parts of the world, but here in Canada, a decent quality USB cable at the dollar store is now up around $4. So that's not economical, because if you think I have 12 devices I can potentially charge at once, but then I need to spend $4 per cable, that means 12 times 4, what is that? $48. It's another $50 in cables. And so I was thinking that for charging, you only really need two wires. You only need the power and the ground. The two data pins you can just leave floating, or you can short together. It doesn't really matter. In my testing, it didn't seem to matter with all the dumb devices, nor with cell phones, so everything seemed to work just fine. So I was thinking, you can salvage electrical wire. If you walk around your area on garbage day, and at least I do here, I walk through my neighborhood all the time where I live. It's getting a little hard now because of the snow, and we'll get to that momentarily. But if you walk through your area, you can typically find broken or used appliances on the side of the road on garbage day. Now I'm talking about like vacuum cleaners or like radios, like stuff like that. Stuff that's not really worth salvaging. However, I bring with me now a pair of wire snips, and when I see an appliance or something on the side of the road, what I do is if it's far until the garbage pickup, like for example, if it's the night before and it looks like a serviceable item, I'll leave it there. I just feel like there are some people who come by and pick stuff up to use it, and that's fantastic. I don't want to prevent them. But when I walk in the morning of garbage day, when I know the garbage truck is coming soon, I'll snip the cords off of all the appliances I see, simply because, and I'll keep the cord simply because that is free wire, basically. With that free wire now this is something I'm addressing to my viewers, and I'll show you guys how to do it in a upcoming video. All you have to do is you buy the USB male ends in bulk, the USB, A, like a standard USB, what you would see on the end of a flash drive, for example. And then you buy micro USB, mini USB, USB-C plug ends, and you can get those for very inexpensive on places like AliExpress, for example, in bulk, with only 2 pads on them, only power and ground. And then with a little bit of soldering, a little bit of heat shrink, you can make yourself some charging only cables. So you make yourself some charging cables with the scrap wire that you pick up from the trash, or whatever. You can salvage wire from your own used electronics or whatever. And then you actually end up with a whole bunch of cables, and the average price goes down from $4 down to 20 cents per cable. So much cheaper. And so then you can start plugging in more things at once. If you have really low draw devices and you're on the go often, so for example, I've got some wireless headphones, and when you put them into charge, they charge at like 50 milliamps or something, very low current. And if I plug them into my power bank to charge, my power bank will actually turn off because it doesn't see enough draw to keep it on. So what I do at that point is you can make these cables, right? But instead of going from one USB-A into one micro USB, you go from one USB-A to 2 micro USBs. You can make like a Y cable. And this Y cable allows you to plug 2 things at once. And so you can draw a reasonable amount of current from your power bank and keep it on. So there's another example. You can charge, I don't know, your wireless mouse or whatever in your backpack when you're going to school, and it'll charge your headphones at the same time. You can plug both at once. So that could be a solution too when you make your own custom cables. Because again, you can buy Y cables, but they're more expensive because they're kind of specialty. It's not everyone that wants them. So the economies of scale is not quite the same. But when you take it upon yourself to build your own charging cables, then you can do that. On top of that, some of you have an aesthetic penchant. Okay, now I'm talking about people that I've had on the podcast, like Senya, uh, or like Steph Piper, or any of these people that have a really good eye for aesthetics, and you see it reflected in their projects. If you make your own cables, you can also buy spools of wire of different color and then braid those wires, or braid or twist or make patterns with those wires, so you can have whatever color you would like on your cables. And so all of a sudden, instead of having a charge cable that looks like everyone else's, you can have like a Aisha. Every freaking time I mistake her name, you can have like an Aisha styled cable with, butterfly patterns or whatever. So for me, being more like pragmatic and not having a good eye for aesthetics, I can just pump out a bunch of cables for dirt cheap especially because I have like a car wiring harness here that I salvage from the recycling. I'll just pump out a whole bunch of cables. But people who choose to make their cables more aesthetic, they can make their own cables, and it can have their own style. Also, another good thing is you can control the wire gauge. So when you order USB cables from AliExpress or eBay, or even like pick them up at the dollar store, you have to take the word of the seller for how thick the cables are. And especially if you have a long cable, like this is one thing I recommend everyone has, is a 2 meter or 6 foot cable to charge their phone in bed, so they can read on their phone while being charged, plugged into the wall, and you don't have to worry about pulling it out of the charge cable. But then you can control your own wire gauge. So you are the one who picks the thickness of the wire. And so you can use thicker wires and, make a much longer run. And I'm talking about, charge only cables. You could make data cables like that too, but at that point, you might lose signal integrity. So I don't know if that's recommended. But the point is, you can make your own cables. And so you can either make them cheaper, or you can make them nicer, or you can make them exactly at your liking, which is a way better solution than just buying random stuff from AliExpress. Now, I have tested some AliExpress cables, and they came out pretty well. One brand, which I'm trying to remember now, you'll have to forgive me. I'm kind of doing this train of consciousness sort of USB cable. And I have tested them, and they worked out pretty well. But I found to power a Raspberry Pi 4, even though my cables tested, they worked pretty damn well, and they had low internal resistance, the Raspberry Pi is still giving me a low current warning on them, which I thought I had solved by buying decent cables. So this is just another reason why you can make your own. Oh, PZOZ is the brand, PZOZ. So you can make your own and avoid these issues altogether, especially if you're doing just a charging cable. So yeah, those are my thoughts on the PCB. I also need to design a case for it. I haven't decided on a form factor, because I may want to stack another one on, but I definitely want to take off some of the the other things, like the 12 volts, for example, onto a different board to do other things with it. So I do want to break out more things. I might end up with a whole like stack of these things where the form factor is consistent, so the people can make their own cases and stuff like that. But for now, this is kind of the deal, right? I'm starting here, and then I'll work my way around into an ecosystem. That's the thought. Another thing I've been thinking of lately is how to best spend my limited energy into giving back to the community. So a lot of maybe not a lot of you, some of you know that I am working on making more in-depth tutorial type videos. I wanted to tackle things like electrical basics and electronics basics. And currently on the live stream channel, I am working on doing a definitive guide to load cells and load sensors in Arduino. And so these kinds of things are the way I plan on giving back to the community. I plan on making 12 of these videos this year alone. And hopefully, it has the side effect. I want to help people. That's the number one. But hopefully, as a side effect, it helps the channel grow, so I can reach more people and maybe even have more potential for collaborations or whatever. But I was thinking another way is I would love to assemble a box with all of the sort of equipment you need to get started in electronics. But looking around on places like Amazon and stuff like that. And so I'm just looking at one right now. It's $37. And it has quite a few things that you would want to get started. But again, I would warn you that most of these things can be got cheaper, bought elsewhere on AliExpress, and possibly even cheaper if you just order them from Amazon separately. But this is what I'm saying. There's some labor involved in assembling these things, and I don't think it's a lot cheaper than buying them separate, but it is cheaper. So if you're really close on a budget, then yeah, watch it. So this one here specifically is the Molence 1818, so 1,818 pieces electronic components. There's 820 resistors. Looks like it's 20 of each from some pretty common and some uncommon, resistances. So from 1 ohm up to 1 meg ohm. You've got a couple of different diodes. So the 1N4007, the kind of standard diode, a couple shot keys. You got 25 of each of those, and then some other diodes, which I don't recognize the part numbers off the top of my head. You get 200 LEDs, which is red, yellow, blue, white, and green in both 3mm and 5mm variants. You get some adjustable pots, some like potentiometers, but it seems like you only get one of each. So 100, 200, 500, 1K, 2K, 5K, 10K, 20K, 50K, 100K, 200K, 500K, 1 meg. And you get one of each of the sort of so this is 10 turns, I guess, and then you get one of each of the sort of the screwdriver ones. You get 2 of each voltage regulator, 5 volt, 9 volt. It looks like it looks like there's positive and negative ones. So 5 volts, 9 volts, 12 volts, 15 volts, and then an LM317, which is the adjustable one. You get some transistors, 10 of each. There's a bunch of transistors. I don't know why you would need so many different kinds when you're learning, but it's 180 pieces. So you got 18 kinds, and you've got 10 of each. You've got a whole bunch of ceramic caps, a whole bunch of electrolytic caps. So it's 300 pieces of the ceramics and 120 pieces of the electrolytics. And then you get some proto board. It seems like you only get four pieces of proto board. And so, like, I think that's a decent assortment, but does it come with a breadboard? That's my question. I don't think so. So you still need to buy breadboards on top of that, which is it's a little bit. See, this is why it's a little bit lacking. It's not really an all-in-one. So they say it is, but different strokes for different folks, I guess. But it is what it is. So that would be $37. It's a decent price. I feel like we can do a lot cheaper and probably more poignant stuff by doing an AliExpress. Maybe that's what I'll do. Maybe I'll do an AliExpress challenge to spend as little as possible to get all you need to get started. So that's that. Looking at things separately on Amazon, it might cost a little bit more. So you can get resistor assortments for $6. You can get 400 LEDs for $10. This is kind of the problem with Amazon buying things separately. The lower cost things have a higher, a ratio of cost to what you get, simply because they're thinking of shipping, right? They're thinking they need to get this to your door. And so you don't really get a discount for buying everything together. You have to buy one listing with everything. But resistors for $6, LEDs 400 for $10. And then another thing, if you're just into pure electronics and you're kind of microcontroller curious, but you're definitely into electronics, you'd probably want some logic chips to play for. I've had a lot of fun playing with logic chips, and so you can get 30 types of logic chips for $22 in a kit from Amazon. And so that might be a good alternative to microcontrollers. But then when you want to add microcontrollers, it's only a couple bucks more. And so I feel like if you pick and choose sort of what you want to order, it's going to go a lot better than ordering, you know, pre-made kits, unless you're like really into one thing. Because again, you can't beat the convenience of like an Arduino starter kit, for example, which will have your breadboards and everything inside, and then courses you can follow. So, yeah, I'd really like to know what you guys think. Should I do a video on, well, first of all, I am planning on refreshing my what to buy to get started in electronics video for 2023. But should I actually go out and like piece together a kit and maybe have links, to the AliExpress sellers and stuff on my website where, I check once a month to make sure all the links are valid, and maybe shop for better deals and stuff like that, and just put it all up there so everyone knows what to decide. Because I feel like when you're getting started, a lot of it is decision paralysis. There's just so much out there and so many opinions to listen in on. Sometimes you just want to be told, can I just buy this? And that might be enough of a service. I don't know. Let me know what you think. But I am liking the challenge, though, to try to keep it under a certain amount of dollars and see what happens. I do like Linus Tech Tips. They often piece together computers for as cheaply as possible and stuff like that. Oh, actually, now that I think about it, that doesn't include a power supply. So we'll have to try to find a power supply for that cost too. Although a lot of electronics can be done at 5 volts these days. So maybe a 5-volt power brick might be useful, or just a 5-volt power supply on, one of those breadboard power supply things. So I think what I'm going to do with that is I'm going to be working on it on the live stream channel. I believe my handle for that is at SE Streams. I probably should have checked before, but that's okay. No, don't worry about that. But if you come down to the live stream channel, you can give me your input on what you think should be included in a very basic sort of beginner's electronics kit. So when I put that together, then I'll be able to take the challenge. And also, if you have sort of like price points in mind, like breakpoints at what point the dollar amount should be for getting into electronics, and then we can try to fit it into the budget. I think that would make an interesting video by itself. So the order of operations is going to be probably the one coming up this Saturday after this podcast released. I'm probably going to work again on the load cell video, and then so get that off the plate. And then next Saturday, probably going to start working on the electronics basics tutorials, because I'm at the point now where I need to finish the first full tutorial and then move on to the next one, the complete video with article and everything. So yeah, that's going to be great. Especially, I hope to see more of you in the live stream, because I do love the community feedback. That's actually the best part of doing YouTube, is being able to interact with the community. So yeah, every voice is welcome, and the more diverse voices I get is the better, because I don't want to sort of exclude anybody's reality from the fact that people want to get into electronics. It would be really nice, though, if I could give classes locally, but it's just not feasible at the moment. Possibly in the near future, we'll see. Maybe I'll set up some vocational thing and sort of volunteer some time. But yeah, at the moment, I feel like I can help the most people out via YouTube, making these tutorials available for everyone. So yeah, just a thought on that. I'd like to close off this podcast talking about sort of like what I think about the most, which is electronics related. And I think it'll resonate with some of you, hopefully. Basically, when I'm like laying in bed, unable to sleep, I have a little bit of insomnia creeping in, but I think it's just from the stress. So I wouldn't worry about it too much. But when I have time to myself to think, the thing I think about the most is low cost DIY alternatives to commercial products. So these things sort of always stay in the back of my mind. Like, for example, a car battery charger. A car battery charger is very expensive, and the price to performance ratio of a low current, we're talking about like 10 amps and lower battery charger, the price is like through the roof, at least up here in Canada, that's for sure. When I know that the basics of a battery charger for a lead acid battery is like, it's nothing. You can just do voltage control, constant current, constant voltage type thing with a maximum voltage, and then you're good. And so you can essentially build yourself a car battery charger with a laptop charger, and then a constant current, constant voltage, DC buck converter, and that's it. You just have to dial in the voltage to a maximum of 13.8 volts, and dial in the current to the maximum able to be handled by your laptop charger, and then you're good to go. And if you want to go even further than that, you can buy a 24 volt power supply or something like that are very expensive these days, and then just put the DC constant current, constant voltage converter on it, and that's it. If you want a display, you can buy the all-in-one current and voltage displays. Like, it's super simple to build, but for whatever reason, even like made in China, bottom of the barrel battery chargers are still very expensive. I mean, I bought one here to experiment with, and the LCD on it is so horrible that you have to look at it like an oblique angle in order to see anything from it. So it's very disappointing that the market has, what I feel like is kind of trash, and it's pretty expensive. And so I have this dream of like building DIY solutions where people who want these kinds of things, they can just build their own at home by ordering the components and having something that is tailor-made to their needs and costs a lot less money. The cost a lot less money part is the best part, but I feel like when you're building something yourself, and this comes back to the conversation about the cables, is that you can make it work specifically for you. And so it's kind of like, it would be really nice to have an Amazon like storefront, but you select like your components, put it all in a cart, and then order it, and have it ship out in one order. A little bit like a Mouser or a DigiKey, but the Mouser and DigiKey type things are really for like components that need to be like traceable and proper and legitimate and whatever. I'm just talking about some place like AliExpress locally, where it's like you just need transistors. Like, you don't need anything like super specialized. You just need, a CMOS chip. It doesn't have to be like from a reputable brand. It just needs to do the job. And it's not like life or death or whatever. So yeah, some sort of like AliExpress electronics market where it's be local. Because like Amazon sort of has that. But again, their model makes it so that you're kind of charged per listing instead of per part. Right? It'd be really nice if you could just like pick and choose and put a bunch of parts in your cart and have it ship out in one order, and have every item have a little bit of markup on it, instead of like the whole listing have a markup that includes like the the buried cost of shipping and stuff like that. I've often thought about curating a store like that, right? I have tons of components here. So if someone in my neighborhood needs 10 diodes, like I don't know if you guys saw in a mailbag probably about 10 mailbags ago now, I bought 1,000 4N001 diodes. And so if someone needs 10 diodes, right, I can easily sell it to them for like $1 or something. And they're not stuck buying a whole bunch on Amazon if they only need 10. right? And then they can have it that very moment instead of waiting 2 days on Amazon or 2 months on AliExpress. But again, I feel like it's not feasible for someone like me who can't be home all the time and doesn't have really that much time to inventory and whatever. It's not worth it. But I mean, something like that would be a cool service. But I feel like electronics enthusiasts and people who know how to repair things and whatever, I feel like we're too spread out geographically for that to be feasible. It's almost like Scotty from Strange Parts, him when he was staying in China and doing the iPhone stuff. It would be kind of that feeling, but more local. I really wish those kinds of things would happen. I probably get asked about once every couple of weeks to fix something for someone, or advice on how to fix something, or should they just buy a new one and trash the old one. It'd be really nice to have sort of like a network of people like myself who hoard parts, and then maybe I can even borrow some some diodes or whatever from someone, and then in my next order take them out of the order when I get them, and then send them back to them or something. I wish the physical components, which are not really that expensive, I wish they were more like the internet, where data is available freely and quickly. But here in reality, physical goods have to be shipped back and forth, and that's just not ideal. So yeah, those are the things that keep me up at night, is thinking about consumer products I would really like my own version of, so people can make their own versions to suit their own needs, and to be less expensive, of course, and a sort of like a storefront, a little bit like DigiKey or Mouser, but that don't need the traceability of you know I guess accurately sourced electronics parts. If you need something fancy, then yeah, DigiKey Mouser, that's your source. But if you just need a diode, just get it through this service or whatever. Anyways, just a thought. I don't know if any of you know what I'm on about in all this, but it's just kind of like my stream of consciousness these days. And possibly at some point, maybe I'll be in a position to open up a makerspace, and then people can come in and grab a couple diodes, a couple of resistors, a couple LEDs, and go home with them and finish their projects up. Or maybe they can just bring their projects to the makerspace, and then we'll just make things together. We do have a makerspace not so close to where I live, but near downtown, sort of like Ottawa is set up a little bit weird. It's like downtown plus south. It's a pain in the butt. Anyways, there's a makerspace there, and if the pandemic hasn't shuttered them, I would love to go there and talk to the people there and see if I can offer some courses there, or I don't really know how it works, but just support them, because I think makerspaces are quite important and hopefully serve to inspire younger generations. So yeah, I'll leave you guys with that before I ramble even more than I rambled now. Next week or next podcast, I hope to get a guest in, but that'll depend on my relative availability, which has been spotty lately. But yeah, let me know what you thought of this episode in whatever comments you can leave. Thanks for listening.